Dobro, ćemo odmah. Dobro, nastavljamo, dakle, 4. forum. Naš sljedeći sagovornik, profesor dr. Vilmos Simon, Budapest University of Technology and Economics i tema pametan transport. Mr. Vilmos, please take the floor.
Yes, hello to everybody. Bolje reći dobar dan svima. I will deliver my presentation in English, but if you have any questions in Serbian, just go ahead. I'm fluent in both languages. So I think I need to share my screen, right? That's the first phase. Just, yeah, that's it. So you can see my presentation. Hopefully you can see it. And
yes, everything is all right.
I can also start the video so you can also see me. Yes. Hopefully everything is fine. You can see the presentation and you can see me also. Can you give a feedback? So everything is fine?
Everything is all right.
Okay.
Please take the floor.
Thank you. Hvala vam. I think we talked a lot in the last years about smart cities, and there was a lot of debate about what kind of smart city technologies are really useful to our society, because in the last maybe 7-8 years, there were a lot of smart city development all around the world, and unfortunately, majority of them were at the end, we can say it a failure or unuseful for our citizens. So when we talk about decision makers or other people who decide in these matters, they become a little bit, I think, skeptical about smart cities because it's more just a buzzword and there are less things which are really useful for the people. So what I want to talk today about is what can we do to really do something what the average people can feel on their skin. Because when you ask 100 people in a city, what is the most important problem they have or the crucial problem they have in the city, daily life, they will say transport. I think in Belgrade you have the same problems like we in Budapest, or the people in Istanbul or New York or Bogota. They are spending a lot of time in traffic jams. They are losing a lot of time. They could spend it with their family or doing some useful things. And we are also spending a lot of money on the fuel, and also we are destroying the air of our cities. All of our cities are really polluted, as we know. So what can we do in this case? I think the intelligent transportation systems are one of the solutions, really effective solutions. It's not just a theory. It started a few years ago already in China, and they are having really good results. So I would tell you about our idea and our initial developments. And the good news are that we find a way to work together with NAAEV. And hopefully it can be some kind of a Serbian-Hungarian cooperation, and we can go to the market and show really what our system can do. So let's start. Let's start with the content I have for today, the agenda. I will talk about the challenges and goals, and after I will introduce our city AI concept and what kind of solutions and services can it provide. We all know the challenges, but I would repeat the most important things. There's a really rapid urbanization going on. What is really interesting that there are cities we don't know about, but they are becoming cities in Africa, in Asia, 20-30 million inhabitants cities. So there are cities we don't know the name about, but they are really big. and they're becoming bigger and bigger. And not to talk about the cities, we all know, and this process is not stopping. All the prognosis is showing that people are moving into cities. If that's a good or a bad process, it's hard to say, but it's happening and we cannot stop it. The other problem is that by citizens, you know, having a higher standard of life, they're all buying cars. Everyone wants to own its own car, so we have more and more vehicles in the cities. We are choking the roads. I have some really interesting experience, for example, in big cities like Istanbul or Bogota, where I was like spending 3, 4, 5 hours in traffic jams per day. And I think that's really not a livable city. The other problem is, you know, it's the acceleration of the speed. We can really, achieve some kind of low speed. We can, of course, we don't want to ride in the cities like on big highways, but still we want to take our journey in shorter time. These congestions are happening on a daily basis. We know that they will happen in the morning and in the evening when people are going back from work, but still they can happen anytime. We cannot, you know, I think you're also experiencing it every day. They can happen anytime. The problem is we started to service some of the cities. We want to work together, and the situation in Hungary and other places of Europe or the world, I think, is the same, that the cities are really having different traffic control systems. They are heterogeneous. They are not connected. So they have, for example, here, they have a separate company for the city roads. They have a separate company for the state roads. They are, you know, of course, they are connected. The roads are connected, but the systems are not. They are collecting a lot of data. So, but this data is also in different databases. They are not using it. And when you ask the cities, what are they doing with the database? They are really not having a good answer. And I'm not talking about the cities only here in Middle and Eastern Europe, but also in Western Europe. They are having this huge database, which is really valuable. And when you ask them, what are they doing with them? They will say, okay, we have some kind of cooperation with Waze or other companies. And when you ask, okay, what you get from them? Nothing. We just give them the data and they use it. So giving it to big companies is not really a good solution, in my opinion, because this is really valuable. When we try to buy information on the market, I'm not telling the name of the companies, but you know, all these big companies who have data about traffic, it's really expensive. We could not afford even to buy, for like 5 or 10 streets. It's enormous amount of money. So when you want to buy it in the market, it's really expensive. However, the cities are not feeling it, that they have some kind of fortune in their pockets, but they are not using it. Also, the traffic control operation, how to share different entities. You have the police, you have the traffic authorities, you have the state ones, you have the local ones. So they are not really well coordinated. So because of that, there are also some traffic jams and happening in the cities, or congestions. So these are the challenges. What we want to achieve, of course, high quality of life in the cities. I'm not just saying about how many time you lose in the traffic jam, but we are losing, I think, if I'm correct, around 300,000 people in the EU because of the polluted air in the cities. Just imagine that it's a high number. It can be compared to some other diseases. What is also important, the cities are not seeing really what's happening real time. So we want to give them some kind of real-time traffic control where they can see the whole city in a control center, and they can react and they can intervene. If they see that something is happening, they can intervene. By this, you can minimize the number of congestions, and you can really keeping the city in move. We want to integrate these traffic control platforms to have one platform, not several. So those traffic operators can really use them easily. What's very important, because the people operating the cities, they are not usually not engineers or not like data scientists. So you need to give them some platform they will understand easily, and they can really make decisions based on your platform. So this is also have a challenge of how to collect real time all the IoT big data for our AI models, but I will tell you about how can we do it. So I'm just showing you a scheme, how can this kind of ITS, intelligent transportation system, what can be the structure of it. As you can see, there is a lot of data which can be collected. For example, you can collect lots of data from smartphones. That's mobile crowd sense, called mobile crowd sensing. We have a lot of cameras in the cities. When we go to cities here in Hungary, they have a lot of cameras. The police is checking what's happening, but they are not using this data for traffic monitoring. So I will show you some solutions. How can we extract traffic data from the cameras? And in even the smaller cities in Hungary, you have like maybe 100, 200, 300 cameras. In Budapest, you have much more. Or we talked with some other big cities, they have like maybe 1,000, 2,000 cameras in cities. So there's a lot of information there which is not collected now. In some of the cities, they are also putting onboard units to buses, trams, metros. So you can collect data from them about, where are the buses, where are the trams, and based on their speed, you can also, see that what's happening in the city. And very interesting technology are the windshield RFID tags, and this is a good cooperation with NAAEV because they can provide us this kind of technology and we can work together. But you have also speed detectors in cities, inductive loops, air pollution stations, meteorological stations. You can measure what's happening with air pollution. You are not just saying that you're doing something, but you can measure what's happening. And based on the air pollution, you can decide what kind of vehicles you will give priority in your cities. We are also, we have a team which is focusing on V2X communication. It's a vehicle-to-vehicle or vehicle-to-everything communication where you can collect a lot of data based on this system. Still, this is the future. But when you check the new vehicles, for example, a Golf 8, they have this kind of V2X, and all the new traffic lights, they have this kind of V2X possibilities. So the technology is here. It will get disseminated soon. We also collect the traffic lights programs, what kind of programs are running in the traffic lights. And there are some other platforms like here, for example, they are collecting a lot of data. Or in every country in the EU, we have a national access point where they are obliged to collect this kind of data and to share it with the researchers. So when we collect the data, here comes the really hard thing. What should we do? A stream processing model should be used. All the big companies are using this kind of stream processing technologies. It can provide us to really in a fast way to process the data and to prepare it for use it for different AI activities. So here you can see the AI model. This is this is the heart, the chakra of our system, because here in this AI model we want to use different machine learning models which can learn the behavior of the city dwellers. This means we can learn how the traffic evolve from day to day and on a daily or a weekly basis. So this can also give us predictions where we have traffic jams. So we try to do it, and it's pretty reliable. We can predict traffic jams. So that's a thing the city authorities could use. Of course, we need some data lakes where we store the data, and we also need to match it on the maps. The third one is the visualization. We want to build a traffic control center where the city operators can see what's happening in front of maps. How about the intervention? What can be, of course, they can see that there will be a traffic jam in 30 minutes. What they can do, they can intervene. So in the left side, you can see the different technologies you can intervene. What we are trying now to do, to try them out if they can work, this is how to modify the programs in the traffic lights. So the new traffic lights are capable for this. For example, the new Siemens Sparco traffic lights, they can be modified from a distance. So we took, for example, some big cities, and some of the big cities already have like 1,000 of these traffic lights which can be modified from a distance. So for example, if we see that congestion is coming, then we can reprogram the traffic lights. You would think it's, it's not an important thing, but it is. In the previous project, some of our colleagues tested it, and by like 2 or 3 seconds, prolonging the green or the red, you can make a huge traffic jam in your city, or you can remove a traffic jam from your cities. So I think this is the most powerful tool to really intervene in a city. What is also important, you can control the public transport. You can modify how many buses will you send. If there's some kind of event you expect, you can maybe send more buses or more frequent trams or anything you can do, or you can see what's happening in the public transport and then to react. VTEX communication can give information to an average people who is driving a car. There's a VTEX communication model. So we can disseminate the information between the drivers, like, okay, there will be a traffic jam. We are not Waze, we are much better than Waze, because Waze will tell you, okay, there's a traffic jam, go around. But for example, in the US, researchers have shown that it is really very bad for the cities, because all these technologies like Waze, they are sending everybody to alternative routes, and then some kind of oscillation, they will overburden this kind of new alternative routes. So there'll be a traffic jam also on the alternative routes. We are doing something different. We can tell the users what kind of route to choose. So this way we can do some kind of load balancing in our system. Waze is not doing that now. So because of that, there are a lot of people, even paying Waze not to bring traffic to their cities, so or their parts of the city. We also want to develop mobile applications for citizens, so every citizens can check, what is the traffic state, what will happen in the traffic, so they can, based on that, they can plan their traveling. We also want to share, to get connected with some platforms which are using connected cars, so we can provide them information also. Okay, I will just show you some ideas or what can we do. For example, AI-based computer vision algorithms are really capable to extract traffic and weather information from video streams. We tried it out and it works. We can provide from a really bad quality camera, for example, what is the number of cars on the road, what is the speed, average speed of those cars, and we can say things like if it's raining or if it's snow is falling. This is important because based on the meteorology, everything is changing and all the predictions are changing. So this means the whole traffic is changing. If you have for example, a rain or we have a snow, everybody is taking their car and even more cars on the street because they are, they're using it like an umbrella. So these are the things we can extract from the cameras. What is a good thing? They can work on both traffic and general surveillance cameras, because there are a lot of general surveillance cameras in the cities, and they're not using it for traffic counting. They can detect traffic in many views, and not only the center of the lane, but in other places also. What is a very promising technology are the RFID tags, and I think this is a great opportunity to work together with NAAEV, because these RFID tags can give us even more precise information about the traffic. We can really detect every car, every speed, so we can have even more precise data. And what's important, all these cars are in a single database, so we can also see what kind of cars are they polluting, so we can, if the city can measure if there's a day there's the traffic, the air is really polluted, then they can decide, for example, to ban some of the cities, so some of the parts of the city. For example, if you have some old cars which are really producing a lot of gases which are polluting the city air, then you can ban them from the center of the city. You can do these kind of things. Of course, the city will decide what they want to do. It's not up to us. The city leaders will decide what they want. But technology is giving them this possibility. So, of course, these tags can, RFID tags can allow this vehicle to have, as I told you, even cases of like when you have like large vehicles like trucks, buses, and the problem is with the cameras, they can The problem is they don't see at night, of course, if they are not equipped with this kind of capability. However, if you have fog or rain or snow or smog, the cameras they are not precise enough. So I think this RFID technology can be really useful to have more precise data about the traffic and also to connect it with air pollution. So then the city can decide what kind of strategy they want to follow. What is more important, I think the stream processing model is also very important to have a real-time processing with no delays in the response and to get some insights from the updated data and to prepare this data. This is kind of pre-processing for the AI models. The people who are working with AI, my team is working it, we know that maybe 70–80% of our time is really spent on how to clean the data and pre-process the data. And after maybe 10–20% of the time goes to running and teaching these models. So pre-processing the data is really important. If you don't do it well, your models will not work and you will get bad results. So what is also important, as I told you already, it is the AI model. We can predict different traffic metrics in real time. So we are using the data, of course, from the stream processing model. We can always integrate new data sources or estimation tasks. This way we are supporting the implementation of real-time classification problems. And what is important, we can utilize technologies that the giants are using, like Alibaba, Amazon, or Ericsson, eBay, Huawei. So it can be really fast. In this point, I think it's very important to provide the technology the city operators can use. They are not data scientists. They are not experts in AI. So you need to provide them an AI model which can retrain themselves, which means you cannot expect from these people to run your models when they have the traffic, because the traffic changes all the time. They open a new street or they close the street or they do anything in the city that will change the traffic. So the models will not be accurate anymore. So you always need to retrain it. So that's very important. If you provide this kind of solution, it should have some kind of automatical retraining because if you don't have that, your models will get obsolete and they will not be so precise if something changes in the city. Okay. What is also very important, I told you, to use AI for modifying the traffic lights. So we can use some control algorithms which are using AI. It's called reinforcement learning, where the traffic lights can really know about, if they can measure the traffic, they can learn when to switch from green to red or yellow, of course. So this is a self-learning capability, which is also good. So the traffic lights can do it themselves. You can train them, and then you can try it out in a pilot, and after you can try it also in a real system in the city. Of course, you can choose different optimization goals. So it's up to the city. For example, if the city decide they want to have a green wave for the public transport, you can do it with this technology. It's the decision of the city if they want to give priority to traffic to public transport. For example, they're doing it very extensively in Amsterdam. I checked some of them systems and they are really remarkable in the sense that they are giving priority for example, trams, buses, or bicycles or pedestrians. So it works really well. But that's a strategic decision of the city that should be decided by them. Not the technology is providing you, so they can do it. Okay, V2X already mentioned you. What is very important, that this is a technology which is really, a technology of the future. But as I told you, for example, in the Volkswagen Golf 8, you already have this kind of technology. There was before a decision in the US that all the new cars will need to have this kind of technology. Now they delayed this decision that, that was a decision with the previous government, previous government, and then the next government change it somehow. But this will not stop the spread of this technology. And as I told you, in all the new traffic lights, they are putting this. So the traffic lights can communicate with the cars. The traffic lights can tell them, to slow down because you will get red. So you can even reduce the amount of fuel you're spending or gases you are putting into the air. So what is important with VTEX, you can collect a lot of data. There are a lot of different messaging services like the CAM, the DAN, the CPM. There are different formats. They can tell a lot of information about the traffic. This is even more precise. We can collect with, for example, with the cameras or the RFIDs. So if this technology gets spread all around the world, I think that can provide us a lot of data, and we can also make intervention based on that. What is important, it should be a multi-vendor framework. So we should be independent, from the vendors. We should have some middleware so we can support any product or implementation on the market. I think this is very important, not to be dependent on one vendor. Here I can see you, this is not, we took some or made some here illustration, how can it look? We are imagining a traffic control center, for example. I'm showing you Budapest. There on the upper photo, you can see, for example, how is the traffic situation on the roads. You can also have different layers. You can also see the predictions. You can zoom in. You can see, for example, for one street or one part of the city. And as you have many layers, you can take out layers of, for example, you can check the cameras. What is the camera showing? You can check all the data. And here we'll have the different alerts, which is coming from the AI. The different alerts are telling you like, okay, there will be a traffic jam or there was an accident here, please react and do something. And then the human, we are not giving the whole control to the AI. The human is there, so the human should decide what kind of intervention should be made here. So you can see all the visualization of map layers, all the EIT devices. You can see also the public transport vehicles, where are they in the city? And you can see the different incidents, as I told you before. And of course, the anomaly alarms and predictions. So then the human operator, then they can decide to change the traffic programs, for example, in the different traffic lights, or they can send notification in the mobile app to the user so they can see what's happening in the city, because usually we don't know what's happening. We are just, going ahead by some navigation or by our head. We can also do some passenger information for the public transport, and using V2X, we can also share it with people. This should be integrated with other CTAI models and cooperating units, of course. So we can connect with police, public road authority, or the national access, national data points. Okay, I told you also about the mobile app. It can collect data, but of course you can announce here if you see an incident, roadblock, anything. It can provide you route planning and some kind of turn-by-turn itinerary for users, and it can display the traffic conditions. You can use icons, colors, and road tolls. But of course, it can show you the future. It's not a waste. It can show you more than the actual situation. It should also be well integrated with the other CTAI models. So I'm just checking. I think my time is running. So I will give you a conclusion. We are dreaming of a new solution based on artificial intelligence. This can provide a real-life control of the city traffic. This is not done before. As I told you, in China, there's a system called City Brain. They are going in this direction, but you don't know too much about that systems. They don't share information. And now I know they started to spread. In Kuala Lumpur, they started to use this system also. So there's a huge market for it, but I'm sure this kind of solution from China it will be hard for them to penetrate to Europe or to the US, because there are a lot of sensitive data involved. So I think the Western Hemisphere will also develop their own solutions, and I think this is the place we can put our solution to the market and to sell it to different cities. This is something the city authorities never get this opportunity to enable them to react and to intervene in real time. By collecting all the information, they can see what's happening in the city. The very important thing is you can prevent these kind of congestions before they occur in your city. This is not possible with nowadays technology. This is a very complex system, so the development of this kind of system needs a really careful work or some cooperation of the partners. So all the partners should work really carefully together so we can integrate in a complex system. And the testing of this system to go production ready is also very important, because we know that researchers can dream of everything and we really bring nice theories on board, but then it should work in the city in real life. So I think a lot of testing. We should do a lot of testing of every of the units, and after you should do really careful integration tests, because it will be really the thing which can make good benefits for the city. But if it's not well designed, it can make also damage for the city traffic. So I'm looking forward to work together with our Serbian partners. So hopefully in the future we will start this joint work, and hopefully maybe in Belgrade when we meet next time. I'm sorry I couldn't be there this time, but next time, maybe in a few years in this conference, we can present the system which is working, maybe also in Belgrade or Budapest, and we can show that the people living in these cities are spending less time in traffic jams. So thank you very much for your attention. I'm really open for any questions or cooperation in the future. So here you can see my email address. So please write me, or you can ask now if you have any questions.
Professor, thank you very much. Sljedeća sagovornica na temu budućnost mobilnosti je profesorka doktorka Marija Kamarđijani, University College London.
Good afternoon.
Ms. Kamarđijani, welcome.
Can you hear me?
Yes, of course.
Okay. So, can you see my screen?
Yes, everything is all right.
Okay, perfect. Thank you very much. And thank you for the invitation. So, today we are going to present a little bit the work that we are doing at UCL Mass Lab and how we perceive the future of mobility. I will start with a brief introduction of the Mobility as a Service Lab, the Mass Lab at UCL. We mainly work on new mobility services and technologies and how we can integrate these to the traditional transport system in order to achieve multimodality both for passengers and freight. And in order to achieve this, we have 4 groups within our lab. We have a group that focuses on behavioral and demand aspects and social acceptance. We design surveys, we estimate advanced behavioral econometric models in order to provide insights about the reactions of citizens towards these new mobility services and technologies. We have a group that works on transport simulation and modeling. We develop simulation tools in order to support industry and authorities to estimate the impact, the multidimensional impact of several scenarios on aspects that they are interested in. Then we have the business innovation models team that works on business innovation models, and actually they translate the findings of the social surveys and the simulations into business recommendations. And we have the policy group that converts all these research findings into or let's say translates the research findings into policy recommendations in order to support authorities to design the frameworks that are required to enable the implementation of new mobility services and technologies. We are mainly a research lab, and we also do some teaching. We established MassLab in 2016, and so far we have 15 research and innovation projects. We have funding from several sources, for example, Horizon 2020, EIT Urban Mobility. We have several publications on the aforementioned topics, and we have 11 PhD students. The future of mobility. It is quite difficult to predict the future of mobility, and there is a lot of uncertainty. So I will not try to give an answer to the future of mobility, but I will say that we would like to have a mobility in the future that is smart, sustainable, green, affordable, and accessible to all. And through our research, we try to provide insights, we try to provide ideas and also tools in order to support the community, the industry, the public sector to initiate new solutions and achieve these goals. And we have a quite wide range of work, but given the time that I have for this presentation, I will just go through one of the projects that we have, and I will describe what we do in order to achieve this vision for the future. I will talk about the Harmony project, that is one of our flagship projects. It is coordinated by us, and it is a 7.7 million project funded by European Commission by Horizon 2020. And the main objective of this project is to develop a new generation of tools, integrated tools, that take into account the new dynamics of the changing transport sector, and in this way to enable metropolitan authorities to lead the transition to a low carbon new mobility era. In this project, the main outcomes is a new generation of software, the Harmony MS, the Harmony model suite, travel demand survey tools. We also do demonstrations with autonomous vehicles and drones. And then we also provide training to authorities and industry in order to learn how to use these tools. In terms of the software, nowadays several of the European cities have a lot of tools to support them into transport planning, but there are also some European cities that they do not have any tools at all. So we are in the process of developing a software that will enable cities to plan for new mobility services, and also how to integrate these new mobility services into the traditional transport system. And through this software are able to simulate several scenarios on a strategic, tactical, and operational level. And of course, the most important is that through this software, they are able to get results regarding a wide range of key performance indicators that are of interest to authorities and industry. For example, they can test a series of scenarios regarding spatial redesign, mobility technologies and services, soft policies like low emission zones, and even hard policies like consolidation centers or electric vehicle charging infrastructure. At the same time, we have developed a smartphone-based travel survey tool that is currently used in the city of Turin and in Oxfordshire County in the UK. And in this way, we collect valuable data from citizens in terms of their travel behavior. And of course, these tools could be used not only by our consortium, but whoever is interested in these tools, so we can discuss, and they can be used by the wider academic society or whoever else is interested. But then, in order to develop this new generation of software that is capable of also simulating the integration of autonomous vehicles and drones in the context of the cities, we also host real-life demonstrations of autonomous vehicles and drones in order to understand what are the challenges that these technologies have. And by doing these demonstrations, we are able to fix the conditions that we have in the simulation software. So these are the Harmony cities. We have 6 cities across Europe, and in Oxfordshire County, in Rotterdam, and in Trikala in Greece, we have the demonstrations. This is the fleet that we use for our demonstrations. We have autonomous vans carrying for logistic purposes, and we collaborate with UPS, who has integrated the autonomous vans in their fleet. We have autonomous buses, and then drones, and also in the case of Oxfordshire, we demonstrate autonomous vehicles that are equipped with drones. So we would like to test how these new mobility technologies can be integrated to have a more optimal outcome. And this is just an example from the way that we work with in the demonstrations. Can you see my screen?
We have a problem, Professor.
Okay, so can you see my screen now?
Okay, we can see now.
Okay, perfect. And so this is just an example of how we work with the ecosystem in each city. We host several co-creation activities in order to understand their needs. Then we propose some concepts, some use cases based on their needs. We work together throughout the process with the authorities, the industry, both local and national authorities. And for example, in Trikala, we co-designed with the community a concept about drones delivering medicines from the city center to the surrounding villages, where mainly we have residents of older ages and with limited accessibility. And we a few weeks before we started the demonstration, the pilot of actually doing these deliveries, medicine deliveries with the drones, and understanding now in real life what are the challenges that we face. We collect data, we record all the barriers, the opportunities that we face, and then we provide recommendations to the regulatory bodies and policymakers. So this is the way we work in terms of research, and also with the city ecosystems in order to support them in building the future of mobility, and also to make sure that the solutions we develop are acceptable not only by industry, but by citizens as well. Thank you very much for your attention.
Thank you, Professor. Budućnost mobilnosti, također Univerzitetski koledž London. Ovoga puta sa nama profesor dr. Nick Tyler. Professor Tyler.
Because I'm muted. Can you hear me now?
Okay, okay.
Okay, fine. So thank you very much for inviting me to give a very brief presentation of the work that we're doing here. And so my laboratory is a little bit older actually than Maria's one that she's just been describing, dealing with mass. This laboratory is based about, it started in about 2003, but we've just actually moved into a new £50 million facility, which has made it much bigger and much more able to do the work with the cities that we've been doing already, but to make it rather better. So what that facility is it enables us to be able to research how people interact with the environment. And one of the main drivers of that research is that our perception, if you like, is that mobility in the future is actually all about people, either people moving or things moving towards people. And in order to be able to sort that out, we need to figure out how do we actually make sure that the way that people interact with that technology is actually one that works with people, and that they are actually at the core of the center, rather than forcing people to fit with other technologies. So the philosophy behind all this is that we take the way that somebody interacts with the environment as based on all of the information that the person has about the environment, and that comes from all of their senses. So what you see, what you hear, what you smell, what you touch, all of those things is how we perceive the environment, and that creates in the brain, processes all of that information in parallel, and then we create a perception of the environment. On the basis of that perception, we then do something. So we would get on a bus, or we would choose to use a micro-mobility, or we would move away from an arriving drone or whatever. That means that the environment changes, and as the environment changes, so we then have to resense it and re-establish that environment. So that's kind of how we're seeing the world working. This is a very simplistic picture of it, and that's kind of what we're doing. So how does that actually turn into what we do with mobility? This is a picture of some experiments we did a little while ago, where this is part of the design of a new tube train for London, which was going to appear in 2024. And this was actually dealing with how people will interact with that train. In this particular example, as they're boarding or alighting the train, What do we do with the design of the train in order to make sure that it works best for the people, and therefore they move more easily and the flow is better, and therefore the train can operate much more smoothly and more economically. And that is actually all part of understanding that whole set of interactions that I've just described. In Pearl, in the current laboratory, what we can actually do is we create environments. We make these environments physically. We can build stations, we can build airports, we can build streets, we can build small rooms, we can build very big rooms. We have about 44,000 cubic meters of space to play with. You can see a small part of it there. What we can do with that is we can then simulate light from anywhere on the planet at any time of day or night. We can bring in the sense of physical and touch, so we can build stations in there and so on, as I was just describing. We can bring in smell, so we can create the smells of environments. Different cities have different smells. Does that change the way that we respond to the environments? And we can actually do all of that at the same time. So we can then see how people actually respond to real city environments and city situations. We can also play with the sound. So that in the sound system, on the left there, you see this is where we prepare all the sounds. This is a three-dimensional sound space controlled over time. And so not only can we basically run trains through the building acoustically, we can also split sound up so that we can make the sound seem further away than it actually is physically. And that means that we can then open up the laboratory to be an even bigger space. That requires hugely complex control of the sound system, hence that elaborate control room and the setup there in the preparation. That means we can make space seem bigger than it is or smaller than it is. We can move within the 3D space. We can shift sounds around to be far away or very high or very low, and so on, all to create the sense that you are not actually in our laboratory at all, but you're in another environment. We can then, having created those environments, we can then take them all away. So we can remove light completely to the extent that you cannot see, for example, your hand in front of your face because there's no light to reflect. What that does is it means that we can then study what the other senses are doing. And so we can start to see what goes on, or we can reduce the visibility, like in a fog, for example, or heavy smoke. We can reduce it to around about 60 centimeters. Combine that with color, that we can then enable us to understand how people interact with conflicting environments where it feels like one thing but actually is another. And then we can make all of that add up by combining all of these things. We can make that into things. We can do things like create explosions or fires and things, so we can look at emergency evacuations. We can look at crowds moving through situations in a state of panic and things like that. We then take all these environments and we test them with people at a range of levels. So we mix neurological, psychological, physiological and physical sensory instruments in order to be able to study how people's brains are interacting, how their heart is working, how much oxygen are they breathing, what are their eyes doing, what are their ears doing, how is their body moving, what is their posture, what is the way they're walking, how are they distributing weight on their feet. All of these are indicators of how people are responding to the environment in super real time at the level of milliseconds. And then we can add to that the psychological experience that people are having in the environment, where we can then see how they feel about that environment. We can then compare those psychological responses with the physiological and neurological responses to see actually what is actually going on. And that informs us a great deal about how things are happening. We're currently extending this, so the building on the left there is the Pearl Laboratory. The one on the right, called CAVE, stands for Clean Active Ventilation Environments, and in there we can study how people respond to different temperatures and humidities and the way that they move around space when it's limited by being interior. Inside that building, we can create other buildings as we require. So we have like a very big Lego set that we can make different buildings with. And we can look at how viruses pass through the buildings, what happens if we ventilate them in different ways, what happens if you've got -5 degrees outside and 35 degrees inside, or the other way around. And so we can test how people operate under these extreme conditions. We can also run a bus into that building, and we can drive the bus on rollers, so we can look at the energy consumption of the vehicle as it is doing as having to handle different kinds of heating and ventilation requirements. A lot of this work has come up because of COVID. So what are we actually doing in there? Well, here's a sort of kind of list. I'll pick out a couple of these experiments that we're involved with at the moment. Next week, we're talking to people about passenger carrying drones and how pedestrians will react to a drone arriving with a four-seating vehicle. How is that going to work? How do we do that? We've got projects going on about warning sounds for e-scooters and other electric vehicles. How do we create a sound that actually works with the human ear but doesn't actually add to the noise of the urban environment? How do we actually look at how people respond to the perceptions of moving vehicles? How do you detect that a vehicle is moving? How do you decide to cross the road? How do we understand that so we can work better when you've got vehicles and people mixing more closely? How do we actually look at how we design public space to enhance communication between people, and also how they will respond, for example, to different methods of control? We've heard earlier about artificial intelligence controls of environments, and how do people actually respond to that kind of control? Also, the energy use within electric vehicles, particularly public transport vehicles. The idea being that we actually need to be able to get more people to shift to exercise their mobility in active mobility, in walking, in cycling, as well as public transport, rather than lots more private transport. So we're sort of working on how we actually create environments where that feels to be the right thing to do. With that, I'll stop there. That just gives you a rough, a very quick description of it. We do a lot of work for cities, for transport authorities, for various government bodies, as well as our own academic research, and some commercial companies are using us for testing ideas, and so we're very happy to talk to anybody about that. Thank you very much.
Thank you, Professor. Naš sledeći sagovornik, dr. Milisav Danilović, Why Tracivity Co. USA, trendovi u beskontaktnom punjenju električnih vozila. Doktore Daniloviću.
Dobar dan.
Dobar dan, poštovanje.
Dobar dan, drago mi je danas da pozdravim sve prisutne i sve učesnike foruma, i ovo je privilegija da se prezentuje na ovako jednom forumu. Danas ću prezentovati trendove u beskontaktnom prenosu električne energije za punjenje električnih automobila. I da krenemo od početka. I imamo dosta slajdova pripremljenih, pa ću truditi se da budem obziran prema vremenu. Ja sam trenutno senior principal naučnik u Elektičnih korporaciji u Bostonu i zadužen sam za razvoj beskontaktnih punjača. Sama kompanija je osnovana 2007. i ima oko 65 zaposlenih, najvećim brojem u kancelarijama u Americi, Švajcarskoj i Novom Zelandu, iako imamo dosta zaposlenih i u Kini i Koreji, gde su nam trenutno ključni partneri. Prednosti beskontaktnog punjenja su razna. Najveći su strah od prazne baterije, eliminišući taj strah, zato što je beskontaktni proces punjenja automatski i može da se konfiguriše da se dogodi odmah nakon parkiranja električnog vozila. I beskontaktno punjenje ima dosta prednosti u kvalitetu, gde vandalizam ili jednostavno sam kabel koji može da se pokida ili da se izolacija naruši tokom vremena, ti problemi jednostavno nisu tako strašni kod beskontaktnog punjenja. Princip rada je dosta jednostavan i poznat oko 100 godina od Nikole Tesla i njegovih pronalazaka. Dva spregnuta kalemova prenose magnetsku energiju sa strane primera koji je obično na podu, odnosno na parking mestu, i sekundar koji je na strani automobila. I na ovaj način energija može da se prenosi dosta efikasno. Obično beskontaktni punjači imaju efikasnost oko 90%. Vidimo ovde na grafikonu u donjem desnom uglu tipičnu efikasnost punjača od oko 10 kW ka bateriji. Kao što rekoh, proces je automatski i korisnik ima velike pogodnosti da koristi ovakav sistem. Sljedeći slajd. U prethodnih 4 godine, prethodni put sam prezentovao 2017. na ovom forumu, u prethodnih 4 godine su se desile mnoge pozitivne stvari za razvoj beskontaktnog punjenja. Jedna od važnijih stvari je razvoj samog tržišta električnih automobila, gde broj korisnika i prodaja raste svake godine i trenutno smo u predikciji agresivnog rasta zbog samog prihvatanja tehnologije, gde su mnoge vlade i mnogi proizvođači automobila rešili da pređu na električne automobile. Znači, trend rasta je veoma agresivan i pozitivan i pomoći će prihvatanju beskontaktnog punjenja takođe. Sledeća veoma važna stvar je razvoj globalnih standarda, gde je vodeći standard SAE 2954 usvojen prošle godine. To je generalni standard koji se odnosi na sve važne aspekte ovog tipa punjača i iz tog standarda su dalje izvedeni ostali detaljni standardi kao što su za komunikaciju SAE J2847 i ISO 15118 standard. Ta komunikacija je preko Wi-Fi se obavlja. Onda zahtevi za dizajn sistema na strani vozila su data u ISO 19363, a na strani primera, na strani mreže, to su IC 61980 i UL 2750 za bezbednost. I osim ovih standarda postoje dodatni standardi za elektromagnetsku kompatibilnost i bezbednost, za recimo da se ne naruši kvalitet radija ili bezbednost ljudi i medicinskih implanta koje oni mogu da nose sa sobom. Znači, ovi standardi će samo da ubrzaju razvoj proizvoda i interoperabilnost proizvoda između različitih proizvođača, što je veoma važno. Dalje, u 2019. godine Vajpricity je izvršio akviziciju Qualcomm Halo kompanije, koja je zajedno sa Electricityjem bio dominantan igrač na razvoju ove tehnologije. Kreiran je jedinstveni pool patenata i tehnologija je isto tako sjedinjena. Prethodno ove dve kompanije su radile na različitom tipu, različitih tehnologija induktivnih zavojnica, ali sada je to grupisano u jednu integralnu tehnologiju, tako da interoperabilnost i kompatibilnost je pojednostavljena i autoproizvođači mogu da imaju samo jednu licencu umjesto dve, tako da sam trošak da se dovede jedan ovakav proizvod na tržište je smanjen. Dalje, razvoj samog sistema je trenutan trend je da i primar i sekundar su razvijeni od strane iste kompanije i dovedeni na tržište. Vidjet ćemo kasnije koji je to primjer, ali u budućnosti se industrija pomera ka podeljenom lancu snabdevanja gde proizvođači automobila i njihovi dobavljači će da proizvedu taj deo sistema, a na strani mreže taj deo sistema će da bude proizveden od strane druge kompanije. Na ovaj način se može brže doći do proizvoda i može se ponuditi bolje iskustvo krajnjim korisnicima automobila. Trenutni proizvodi na tržištu su BMW, koji je hibridni automobil i taj punjač je relativno niske snage, zato što i baterija je manja na hibridnom automobilu. Također McLaren je prvi izbacio proizvod sa većom snagom od 11 kW pre 2 godine i taj automobil je dosta skup. Sledeće godine imamo dva nova proizvoda, jedan dolazi od korejskog proizvođača luksuznog vozila Genesis. I taj sistem je 11 kW takođe i u Kini imamo isto luksuzno vozilo FAW Hongqi koji je u sličnom cenovnom rangu kao i Genesis. Tako da su ovi sistemi koji izlaze sledeće godine, oni su pripadaju sledećem tehnološkom talasu i dosta su nižeg cenovnog ranga nego prethodni sistemi i imaju bolje performanse u smislu efikasnosti i pouzdanosti. Šta dalje posle 11 kW, sistemi koji izlaze sledeće godine? Mi vidimo razvoj sistema veće snage od 22 kW za manje kamione, taksije i flote vozila. Dalje razvoj sistema do 50 kW za dostavna vozila i autonomna vozila. I dalje za kamione srednje veličine sistemi od 150 kW do 500 kW. Trenutni sistemi koji su na tržištu ili koji će da izađu na tržištu sledeće godine su unidirekcionalni, znači prenose snagu samo od strane mreže ka automobilu. Budućnost je bidirekciona, znači automobil će imati mogućnost da prenosi snagu nazad ka mreži za stabilizaciju mreži ili za napajanje stambenog objekta u slučaju nestanka električne energije. I posle bidirekcionalnih sistema ćemo imati poludinamičke ili dinamičke sisteme gde automobil će moći da se kreće i puni u isto vreme i tu je naročito pogodno za, recimo, za taksi vozila na aerodromima gde se taksi kreće malom brzinom i jedan segment tog parkinga za taksije može da se uredi da bude poludinamički prenos energije. Da sumiram, prepreke ka široj komercijalizaciji beskontaktnih punjača su otklonjene u poslednje 4 godine usvajanjem samih standarda koji dalje donose kompatibilnost između proizvođača. Licenciranje je pojednostavljeno takođe i masovnije usvajanje električnih vozila je generalni trend, tako da ova tehnologija će samo dalje da se razvija i postane masivna. Da sama komercijalizacija ulazi u neku širu primjenu u sledećoj godini i interesantno prva tržišta će biti u Aziji sa Genesisom, odnosno Hyundaijem, u Koreji i u Kini sa lokalnim proizvođačima. Dalje će se razvijati na Evropu i Ameriku u kasnijim godinama. Naravno, premium klas automobila će biti prva koja će ponuditi beskontaktne punjače krajnjim korisnicima i dalje će kako se tehnologija usavršava i pojednostavljuje i cena spušta, onda će i automobili srednje klase moći da priušte beskontaktne sisteme. Hvala puno i ako ima nekih pitanja, rado bih odgovorio.
Gospodine Daniloviću, hvala na učešću u forumu.
Bilo je zadovoljstvo.
Sada se slikom selimo u Tursku, tačnije Yasser University. Tamo nas očekuje profesor dr. Graham Hansen.
Yes, good afternoon.
Good afternoon, Professor.
This is a most interesting forum, to put it mildly. I like the direction of some of what has been said. I've got a PowerPoint presentation I want to show here in a video, so at some point somebody has to make me a host so that I can bring up that PowerPoint. In the interim, am I host yet? I can't see, but in the interim, I want to make a point that everybody that I've listened to this afternoon have talked about urban mobility in the terms of cars and so on, roaming the streets of cities without really recognizing, or so far I haven't heard anybody acknowledge the imperative that the European Union has stated of having car-free cities in Europe within the medium to long-term future. Now, that's partly what I want to address, and I'm, how can I say, as an urban mobility designer, as distinct from an electronics engineer, etc., I have a completely different view of what future urban mobility may be. It's an obvious honor to be invited to speak at this forum because I'm impressed that the National Association here is broadening its horizons to embrace a wider view of urban mobility. I'm, as I've said, an urban mobility designer and the founder of something which we call the Human Power Initiative here at a university in Western Turkey. I'm also formally an advisor to an Italian NGO called City Space Architecture. The point is made about urban because that is the environment where most of us live and vehicular usage in this environment accounts for 30% of the world's carbon emissions. But you all know that, or we wouldn't be having this forum about electric vehicles. But there is a new element to be brought into the discussion today about the absolute nexus between the public realm and future urban mobility. We cannot view urban mobility just in the context of modes of transport. Greater consideration is required about utilization of public space. Public space being the area between your front door or gate and the entrance to your workplace. Development of modes of transport must reflect a redefined urban lifestyle, which includes more radical solutions to urban mobility than we are currently seeing. The UN Habitat has just completed another very large Innovate for Cities conference. In the closing session, there was an attempt to summarize outcomes of this conference. There were 6,000 attendees, around about 200 presenters like myself, and an overriding theme was down prioritizing cars and then buses, transforming the priority from cars to people, that is, people in public spaces, with an emphasis on an attractive invitation to a new urban lifestyle. Interestingly, another takeaway from the same conference was the requirement for big data, embracing people and street activity monitoring to calibrate. I'm sure many of you here can understand the implications of what I'm saying. So let's take a walk around the future of urban mobility in the public realm. In the accompanying presentation, if I can possibly start this PowerPoint presentation. Now, I'm going to try here. Does anybody know if I'm made host yet?
Yes, yes, please.
Okay. So now I'm going to try and click on share screen. There we go. And here we go. Can you all see that?
Okay,
possibly?
We can see.
Great. We all have grown up surrounded by cars and the related industries. It is perhaps impossible to conceive what cities and the public realm looked like 100 years ago. And my page is not moving. Why not? Okay, it is. And so we have here an example of Manhattan in 1920. The streets didn't have a lot of cars. People were relaxed enough to stand there in the middle of the street. And there was a plethora of people in the streets. And in Paris, 30 years prior to that, people thronged the streets. However, a new mayor is in Paris these days, Anna Hidalgo, and she has fresh ideas for the riverbanks of Paris and so on. What is obvious when we look at the traffic pollution that we know in Paris and other major cities is there is huge competition for public space. Competition between those individuals who are married to their cars, their private personal transport, and other urban citizens who are not so married to their cars, but seeking some nirvana of relief from traffic stress, congestion, and pollution. I imagine at this moment you can all grasp the point being made here, that it is not really efficient to talk of smart vehicles, electric or otherwise, without taking into consideration the primacy of the public realm. Last year, COVID time, no sooner had bicycle paths spread across London, Milan, than motorists forgot about any health benefits and screamed to retake the streets for cars. Within the past days, London has introduced the ULEZ or ultralight emission zone, after advertising about it for months, requiring stiff financial penalties for polluting vehicles within these zones. Now in force, there is an outcry by motorists without e-vehicles, making demands to be allowed to continue to pollute the environment. So here are the first of several points I want to make, perhaps obvious as they may be. There's a lot of competition for public space. Motorists are highly unwilling to give up the personal space of their cars. Basically, screw the planet, my personal needs override your personal needs and override climate change issues. There is an overwhelming need to redefine urban lifestyles, driven by design and driven by incentivization. Whereas some urban stakeholders dream of re-greening their cities, some actors are actually building vertical forests like this. You can possibly, some of you may actually recognize the Pirelli building there in the background of Milan. There is insufficient time here to elaborate further about public space or redefining urban lifestyles. So let's investigate what is happening within urban mobility and modes of transport. There is a plethora of electric vehicles on drawing boards, well into prototyping, all of them with rather heavy price tags, as you've heard from previous speakers, and all of them requiring recharging infrastructure, placing, of course, loads on energy grids anywhere in the world. All of this ably supported by the Green Deal rhetoric of the European Union and burgeoning bureaucracies imposing multi-layered demands for documentation. The European Union, for its part, has decided on a policy of car-free cities, frequently expounded and promoted, while completely missing the main point of how are urban citizens going to be forced into giving up their vehicles and engage with public transport. How is this going to happen? That the European Union will legislate people out of their cars? Really? The only solution is to incentivize people out of their cars by offering alternative modes of personal transport. Now, human power, that which comes from our legs, founded cities X hundreds or X thousands of years ago. Everything was walkable. Many of those cities remain today, as equally many of the American cities or towns founded around cars are in steep decline today. I'm sure some of you can get the connections. Human power in the form of cycling has long been calibrated and recorded as being considerably more efficient at urban mobility in dense settings. But it comes with drawbacks. For example, highly efficient as a velomobile may be, the green guy here, it poses considerable risks in urban traffic. Again, I'm sure everyone can make the connections. So the next point to be made about the future of urban mobility shows that cycling seems to represent some benefits. Cycling, however, in its present form has some drawbacks. The addition of e-motors to bicycles has resulted now in the ubiquity of L-assist or e-bikes. But like their four-wheeled e-brothers, e-bikes don't come cheaply or lightly, and there's still the weather to contend with. We at the Human Power Initiative embraced the idea of lightweight vehicles and developed a generator based on the slow-moving wind turbine generators that could be run from the simple action of pedaling. Currently harvesting 58 volts from modest cycling, that is a step up from the average bicycle generator, which typically produces 6 volts, but is hardly going to provide sufficient power for a typical 250-watt e-bike motor. So recently we adapted the same generator to run off the momentum of the vehicle, independent of pedaling action, In other words, we have developed a continuously self-charging hybrid lightweight vehicle. It does not require recharging generally. It opens a Pandora's box for rethinking lightweight vehicles that answers to weather protection, that enables modest load carrying, answering to sustainable urban mobility like no other vehicle I've seen. We've played with these designs, but we don't claim yet to have the perfect body form for a lightweight vehicle. But the hybrid transmission developed at the Human Power Initiative will be part of the mix of personal transport for future urban mobility. The only other urban mobility design that comes close to our design philosophy is the Canadian Electron, which also features a generator and a chain drive, and coincidentally produces lightweight vehicles in the same yellow color. For mine, the vehicle is too heavy, does definitely require recharging. No, we don't have any communication. Electron has come a long way in the past 4 years without any subsidies. When I first saw it 4 years ago, it was blue, but I feel it will be part of the mix of hybrid or electric assist LWVs in the future. Many of you may have already seen this pretty picture of something called a biohybrid, widely promoted by an automotive parts producer, complete with overcomplicated suspension, too many wheels, too much of a purchase price, and a need for constant recharging. Not at all likely to be successful for part of the urban mix of personal modes of transport. This German design has some common design elements with our work. It has unnecessarily too many wheels and the requirement for a charging point. I see this as having limited potential. There is a plethora of designs out there, some of which are pretty and may be part of the mix of future mobility. If we look at Toyota, they've opted for mini cars, so to speak. But look at this, each of these cars is attached to a recharging point. So I see a very limited future for these. However, maybe I'm wrong. Maybe this type of design is the future of urban mobility. Maybe it'll be something like this, but I don't think so. The penultimate question is that institutions making all the claims about future urban mobility and car-free cities steadfastly refuse to invest at all in design thinking about the future physical form of or modes of urban mobility in the medium or long-term future. There is zero, or specifically -0 encouragement for innovative or disruptive design thinking about that future. There is an apparent blindness to answering the greatest systemic choice of all, how to get people out of their cars and into a more sustainable urban lifestyle. So far, this forum and my contact, Milan Proken, of this National Association of Autonomous and Electric Vehicles, which is amazingly difficult to say in English. This is an innovative step to try and gain for Serbia a slice of the pie for future urban mobility. I hope the gods of urban mobility project funding can also recognize an imperative to change their current direction and embrace both the public realm as an integral part of urban mobility and to encourage collaboration between innovative entities. In case anybody wants to contact me, there are my necessary details. Thank you, everyone, and I'll get off my bike now.
Thank you, Professor. Naš sljedeći sagovornik, diplomirani inženjer Nikola Bulatović, direktor Syncrotek d.o.o. Gospodine Bulatoviću, dobar dan, čujemo se, vidimo se. Da čujemo vaše istraživanje i da vidimo vašu prezentaciju.
Hvala prvo na pozivu i drago mi da sam prvi put sa vama. I nekoliko reći samo o firmi pre nego što krenemo u ono što je zanimljivije. Firma osnovana 2004. godine, ja sam direktor i osnivač. Bavimo se razvojem hardvera i softvera za automobilsku industriju. Naši najveći, da kažem, partneri, odnosno mušterije su članice Volkswagen grupacije. Sa njima sarađujemo već nekih skoro pa 20 godina, kontinuirano i, da kažem, saradnja u posljednje vreme dobija i na sadržaju i na količini materijala koji zajedno radi. Nešto o našem portfoliju. Kako smo uopšte počeli saradnju? Počeli smo saradnju tako što sam ja radio sa jednom firmom, bio sam zaposlen u jednoj firmi u Nemačkoj i tu smo, da kažem, tu sam počeo da radim kao inženjer automatike. Zatim sam se preselio ovde, jedan od dece o kojoj je pričao Branko Kovačević, profesor. Tako da sam počeo da radim na sistemu automatizacije, klimatizacije, odnosno thermal management u električnim vozilima. Zatim smo bili u pravom vreme na pravom mestu. Kada je tamo neke 2008. Elon Musk počeo da objavio svoje roadstere, ne znam ja šta, kad su svi mislili da je onako sve to, da kažem, preambiciozno, neko se u Volkswagen grupaciji setio da ok, ovo bi možda ipak uspeo i onda se pojavio taj pilot projekat električnog golfa i posle par, da kažem, godina nekog istraživanja, kad je, da kažem, pilot već krenuo, neko se setio, ok, kao dobro, imamo kao auto koji ide, imamo auto koji kao u redu je, kako ćemo da grejemo ovo čudo? I to je neko pitanje koje ceo dan danas od 10 sati na konferenciji niko se nije pozabavio pitanjem kako uopšte grejemo električna vozila i odakle nam energija za to, toplotna energija. Oni su prvo krenuli da rade sa, naravno, iz baterije, kao svi, kao pokoj, uključujem struju, uključujem peć i onda će da bude toplo. Međutim, šta se dešava kada se uključi peć? Problem nastane u tome što vi kad imate jako hladne uslove na polju, vaš domet koji je projektovan za ne znam ja koliko kilometara, uzmemo na primjer 200, kada je na polju minus 10 stepeni, pada on na 100. U gradskoj vožnji još više, zato što se više grejete u gradskoj vožnji nego što se vozite. Non stop je stani kreni, to je prosječna brzina 20-30 km na sat i vi više energije potrošite za grejanje nego za ono zašto je zapravo baterija služi i tu se svi slažemo, a to je da iskoristimo tu energiju koju smo napunili iz utičnice da se dovezemo iz tačke A u tačku B. Ali opet, ja se opet ne znam, nisam toliko, da kažem, učestvovao u tim budućim konceptima, budućim znanjima. Mi se držimo nekih tradicionalnih, klasičnih vozila. Radili smo sa njima, tako da naš thermal management je baziran na tome da ćemo, da kažem, ipak zadržati jedan deo, da će se, da kažem, tradicionalna mobilnost upgradeovati u smislu efikasnijih vozila, efikasnijih rešenja, ali da ćemo ipak imati neki auto koji izgleda otprilike ovako. I za ovakav auto vam treba, klasičan auto, treba vam 6-7 kW grejne snage da zagrejete na, recimo, minus 10 stepeni Celsijusa. Što kad imate motor sa unutrašnjim sagorevanjem, nije nikakav problem. Imate motor koji je efikasan 20%, 70-80% date na grejanje i nikom ništa, super. Vozimo se, grejemo se, nije problem. U električnom automobilu mi nemamo takav luksus. Ono što imamo u motoru sa unutrašnjim sagorevanjem, to je jedna peć koja se pokreće na točkovima. Kad imamo električno vozilo, vi imate maksimum 10% gubitaka. Koliko god da ste efikasno napravili, bit će nešto gubitaka toplotnih, koji u principu u klasičnoj varijanti kada se grejete na neki električni grejač u kolima, prosto izbacite napolje. Tu nije mnogo energije, ali otprilike tu može da bude dosta u kombinaciji ako uspete da nađete sve druge izvore energije koje se nalaze na raspolaganju i na pametan način ih prebacite tamo gde treba da bude u kabini. Zatim imamo bateriju, koja je takođe izvor toplotne energije, naročito kada se radi o, na primer, sceneriju u kojoj imate brzo punjenje, to je, recimo, današnji punjači idu do 200 kW snage, to je isto jako efikasan proces, ali nije 100% efikasan. Imate tu neke gubitke i tu energiju koja se troši, tu toplotnu energiju, možete iskoristiti za preconditioning automobila, da iskoristite energiju da dok je auto na punjaču, vi zagrejete unutra kabinu ili da, sad pričamo konkretno o grejanju, hlađenju nije problem. Hlađenje se radi isto. Zatim imate nešto što se nalazi u ambijentu. U ambijentu imate toplote koliko hoćete. Mislim, klasične klima, uređaji koji imaju ono što kažemo invertor klime, mogu da rade imaju taj mod da vi okrenete, da grejete unutrašnjost, da hladite spoljašnjost. Mislim, vrlo jednostavno. Automobilima to nije moguće, objasnit ću posle zašto. Nije moguće jednostavno uraditi promenu moda tako što promenite izvori i ponor energije, jer postoje fenomeni o kojima će kasnije biti reč. I naravno imate toplotu koju ste već, kada je napolju hladno, kada ste vi već iskoristili neku energiju da zagrejete auto u unutrašnjost automobila, vi imate neku energiju, pošto vazduh mora da cirkuliše, pošto upumpavate svež vazduh s polja, da se ne bi stvorio nadpritisak u kabini, vi uvek imate neke izduvne prostore i vazduh koji je zagrejan izlazi. To su takođe neki gubici koji mogu da se pokupe i sve to zajedno kad saberemo. Znači, to uopšte nije malo. Znači, da u ovakvoj nekoj situaciji kad imate neke standardne automobile sa standardnim izmenivačima toplote, vi možete da dođete do neke 4,5 kW koje ste bacili napolje, a niste iskoristili za grejanje, što bi vam, da kažem, produžilo domet za neke značajne cifre. Sad, opet, ok, sve je to lepo, ali sad ljudi kažu sa pravom, pa dobro, zašto mi napravimo? Ipak, ok, ja ću da uzmem grejač, ja ću da stavim na kraju svega, pošto sam napravio već auto koji radi, koji je sve funkcionalan, sve ok, šta će meni sad to? I to je vrlo legitimno pitanje, zato što je pitanje na kraju odnos cene i onoga što dobijete. Kao inženjer koji se bavi time 20 godina, meni je sramota da imam električni auto bez toplotne pumpe. Kao vlasnika firme, potpuno razumem razloge za to. Izuzetno je skup proces, izuzetno je komplikovana tehnologija za koji god put da se odlučite, da li neki od puteva koji trenutno postoje na kojima smo i mi radili, za koje smo upisali algoritmu upravljanja, ili nešto poput onoga što smo mi smislili dok smo gledali sve to šta bi moglo da se uradi, zašto ne iskoristiti sve moguće izvore, kako napraviti sistem koji bi bio, da kažem, dovoljno prijemčiv svima, da kažu, ok, mi ćemo kupiti taj HVAC, jedinicu za grejanje i hlađenje, koji u principu nikoga ne zanima. To je, treba da stoji ispod kontrolne table i da greje i hladi. I to uopšte nije zanimljivo. Znači, tu nema ni snage, tu nema ni neke komunikacije, ništa fancy to nije, to samo greje i hladi. I to je vrlo nezahvalno biti na kraju lanca, ali opet, mi smo, da kažem, osmislili sistem koji bi mogao da kažem, zameni konvencionalan sistem, u smislu da smo razmišljali kako bi mogli da zamenimo isparivač koji se nalazi u HVAC-u i da kažem da izmenjivač toplote koji se nalazi na frontu automobila iza radijatora, kako da pomerimo sve u jednu celinu, da spakujemo zajedno, da izbegnemo prekidačke ventile za promenu ciklusa, za promenu radnih režima rashladnog gasa i da napravimo sistem koji je dosta jednostavniji od onih na kojima smo radili. Zato što je napraviti algoritam upravljanja za sisteme na kojima smo radili grozomor. To je potpuno, to je proces koji traje 3-4 godine. Mislili smo da bi mogli nešto da napravimo što bi bilo, da kažem, jednostavnije. I sad u principu, u celom tom procesu koji smo mi prošli, mi smo naučili da modeliramo sistem, da napravimo termički model kompletne kabine, termičke procese koji se tu nalaze, da bi mogli da šaljemo, da uradimo softverni loop simulacije pre nego što pošaljemo, da kažem, gotov proizvod na testiranje. Prosto to je bilo deo kontrole kvaliteta. Morali smo da imamo kompletan model okruženja, što ću u principu pokazati sada. Iz tog modela smo dobili, da kažem, aplikaciju, znači ovaj sistem koji smo vidjeli malo pre. I sada u principu model koji smo razvili može da setuje temperaturu spoljnu, može da setuje željenu temperaturu na izlazu, to su paneli, znači oni kako se to zove, ducts na engleskom. Otvori za vazduh koji se nalaze na instrument tabli. Mi možemo da setujemo temperaturu tu, da setujemo da li ćemo recirkulaciju ili svež vazduh. Možemo da setujemo brzinu ventilatora koji pumpao vazduh u kabinu i da pokrenemo simulaciju. I sada u principu vidite kad na minus 12 stepeni, recimo, na primjer, selektujemo 50 stepeni da uduvavamo u kabinu, što je, da kažem, razumno očekivati za tako neke uslove. Vidite kako se vazduh koji ulazi u kabinu greje preko izmenjivača toplote, jednog od izmenjivača toplote. Sad možemo da menjamo uslove, da menjamo temperature. U principu ovaj simulator koji nam je služio za kontrolu kvaliteta, ispod se ne nalazi kompletan fizički model celoga procesa, ali se nalazi funkcionalan model koji nam je daje dovoljno dobre predikcije šta će se dešavati u realnosti, da možemo da napravimo iz njega, da kažem, jako dobre rezultate. Inače, algoritam upravljanja koji smo razvili i modifikovali za ovaj proces u saradnji sa partnerima. Šta je prednost? Znači, na kraju, kada zanemarimo sve probleme koji postoje da kažem, na strani odluke da se sistem ne komplikuje, da se koristi jednostavan grejač iz baterije, pa postoje jako puno korisnih stvari ako koristite toplotnu pumpu. U principu, na prosječan domet da kažem, ako bi svi vozili električna vozila, prosječno povećanje dometa, ako bi svi imali toplotne pumpe, bi bio oko 20%. U zimskom periodu bi domet bio povećan za nekih 40%, odnosno ono što sad imamo u zimskim uslovima. U skladu sa time, prosječna potrošnja baterije bi bila 20% manja. Takođe, zbog manjeg broja ciklusa punjenja i pražnjenja bi imali 20% duži vek baterije, što nije uopšte zanemarljivo. I naravno imali bi 20% manji carbon footprint, zato što je prosto vrlo logična posljedica svih osnovnih ušteda. Složit ćemo se u poređenju kada pogledate sada, kada imate motor sa unutrašnjim sagorevanjem pa ste prešli na električni, ovo izgleda malo, ali kad imate električna vozila, a pogledajte koliko je ušteda na svakom od električnih vozila, to ipak mislim da nije zanemarljivo, ali to je već drugo pitanje. Ono što mi nudimo kao iz našeg portfolija, to je upgrade heat pump sistema konvencionalnim vozilima, nudimo naše, da kažem, proprietary sistem i naravno svaku vrstu podrške za nekog ko se usudi da ide tim putem, što je put kojim se, moram da kažem, već ide. Hvala.
Hvala vama. Profesor dr. Aleksandar Nešković i diplomirani inženjer Marko Marković sa Elektrotehničkog fakulteta u Beogradu. Istraživanje, izazovi i funkcionalnost autonomne vožnje. Gospodin Marković će ovoga puta predstaviti projekat.
Do sada sam na ovakvim vrstama događaja bio član publike, a evo po prvi put, zahvaljujući profesoru Neškoviću, mi je veliko zadovoljstvo što mogu da se oprobam i ulozi predavača i danas ćemo pričati o autonomnoj vožnji i njenim osnovnim izazovima i funkcionalnosti. Što se samog termina autonomne vožnje tiče, ono se tiče samo vozećih vozila i transportnih sistema koji se kreću bez ikakve intervencije vozača. Društvo inženjera automobilske industrije je 2014. godine donelo ovaj J3016 standard za definisanje različitih nivoa razvoja same autonomne vožnje. Dakle, sam proces je kretao od nekog nivoa 0, odnosno bez ikakve automatizacije našeg vozila do krajnjeg, odnosno onog ciljnog nivoa 5, odnosno potpune autonomije autonomnog vozila. Da bi autonomna vožnja funkcionisala baš onako kako smo mi to zamislili, sva vozila će morati da budu povezana i međusobno, a tako i naravno i sa svim okolnim sistemima, kao što su recimo sistema mapiranja i nadzora, hitnih službi ili usluga održavanja puteva, pametnih semafora ili raskrsnica. I takva komunikacija mora biti izuzetno pouzdana i imati izuzetno malo kašnjenje. I nazivat ćemo ih URLLC komunikacijama. I URLLC je nova kategorija servisa 5. generacije mobilnih mreža pružajući pouzdanost od čak 99,999% sa ciljnim kašnjenjem od 1 milisekunde i naravno zahtevanom end-to-end bezbednošću, odnosno bezbednošću s kraja na kraj. Ukoliko uporedimo ovo vreme reagovanja naše komunikacije od 1 milisekunde sa treptajem oka, koji po nekim studijama iznosi oko 300 milisekundi, možemo zapravo i da vidimo koliko su brze ove naše komunikacije. Što se tiče, naravno, kao i u svakodnevnom životu, na putu do nekih naših ciljeva stoje neke razne prepreke, izazovi koje mi trebamo da rešimo, je li tako? Tako da je naravno i u autonomnoj vožnji postoje određeni izazovi, a ovdje su izdvojena neka karakteristična 4 izazova za samu vožnju. Što se samo prvog tiče, naravno da karakteristike, odnosno performanse samih zaključivanja zavise pre svega kakav je kvalitet snimljenih slika. A na kvalitet snimljenih slika uglavnom zavisi okruženje, da li to bili recimo vremenski ili neki svetlosni uslovi, da li to bila sama rezolucija slike ili pak udaljenost između kamere i samog objekta. I naravno Nacionalna uprava za bezbednost saobraćaja je sprovela jedno istraživanje upravo iz ovog razloga. Postavili su samo jednu kameru kao jedinu vrstu senzora u svoje vozilo i kao tako pustilo u rad. Bila je kiša, noć je bila i na samom kolovozu je naišao jedan pešak u tamnoj odeći koji je gurao svoj neosvetljeni bicikl i došlo je naravno do nekih nezgoda, čim se zaključilo da se donošenje odgovarajućih odluka putem samo jedne vrste senzora u vozilu uglavnom nedovoljno. I stoga se pristupilo spajanju alternativnih senzorskih modaliteta za percepciju, kao što su recimo i spajanje sa nekih ugrađenih senzora u vozilu, kao što su lidar senzori ili senzora sa okolnih pametnih raskrsnica ili čak i naravno međusobna interakcija senzora iz drugih vozila. I takva jedna tehnika se naziva fuzija senzora. Naravno da na performanse samo zaključivanja, osim same tačnosti iste, na nju utiče i njeno kašnjenje. Odnosno, ukoliko mi imamo neko malo povećano kašnjenje, performanse takvog zaključivanja opadaju, tako da jedan kompromis ove dve stvari uvek jedna, da kažemo, bitna tema u autonomnoj vožnji. Rešenje ovog izazova se ogleda kroz neke obećavajuće tehnologije u budućim 6G mobilnim mrežama, a neki od najkarakterističnijih predstavnika su prenos mimo sistemima, prenos milimetarskim talasima ili čak korišćenje rekonfigurabilnih inteligentnih površina. Naravno, u poređenju sa ogromnom veličinom moćnih grafičkih i centralnih procesorskih jedinica na samom cloudu, Edge server dosta teže podnosi taj veći broj zahteva sa većeg broja vozila. I na taj način, upravo zbog svojih ograničenih resursa. Jedno rešenje se ogleda upravo kroz ovde postavljenu zajedničku optimizaciju samih resursa, znači donošenje optimalne odluke o alokaciji tih resursa i o optimalnoj odluci o rasterećenju resursa sa Edge servera. Naravno, ukoliko mi ne obezbedimo na kraju privatnost i bezbednost naših podataka, sve ovako, da kažemo, jedna lepa priča može isto tako lepo i da padne u vodu, je li tako? Što se tiče neke osnovne funkcionalnosti autonomne vožnje, ona se ogleda kroz ova osnovna 4 funkcionalna modula, gde u okosnici stoji modul prikupljanja podataka, od kojih se, da kažemo, podaci mogu svrstati u neke 2 kategorije. Prva se tiče samih podataka detekcije, odnosno podataka prikupljenih sa ugrađenih senzora samog vozila, dok drugu kategoriju podataka čine podaci o samom stanju vozila, znači kojom se energijom raspolaže, kakve su mogućnosti samog vozila. Kasnije se tim prikupljenim skupovima podataka dalje upravlja distribuiranim učenjem na samim krajnjim uređajima i takvi parametri tih obučenih lokalnih modela se postavljaju na Edge server u cilju jedne kompletne agregacije. U tom nekom kontekstu autonomna vozila u jednoj mreži mogu zajedno da treniraju taj njihov zajednički model. Što se tiče levog modula, to je pomenuto donošenje optimalne odluke o rasterećenju samih resursa, tako da bi se time, to je jedan jako bitan modul po pitanju pogotovo bezbednosti u samoj autonomnoj vožnji, tako da ćemo se na narednom slajdu malo detaljnije pozabaviti time i naravno kasnije o samom donošenju krajnje odluke kao konačnom koraku ove jedne petlje funkcionalnosti. Znači, naravno da je zbog ograničenih računskih resursa ili raspoložive energije vozila uvek potrebna njima pomoć okolne bazne stanice, odnosno tačnije samog Edge servera koji je implementiran u baznoj stanici. Tu se definiše jedan problem donošenja optimalne odluke o rasterećenju i optimalne odluke o alokaciji samih računskih resursa. Rešenje takvog jednog postavljenog problema ogleda se kroz definisanje jednog modela feed forward neuralne mreže zasnovan na multitask learningu. Konkretno, znači, optimalna odluka o rasterećenju se ogleda kroz jedan multi-class classification problem sa gubitkom cross entropija, znači, da kažem u slobodnom prevodu nakrsne entropije, dok se alokacija samih resursa ogleda kroz jedan problem regresije, imajući, znači, jedan gubitak srednje kvadratne greške. Naravno, tokom same MTL obuke koristi se optimizator radi minimiziranja ovog krajnjeg zbirnog težinskog gubitka gde svaka grana ima svoju težinu. Dakle, ovakav jedan model duboke neuralne mreže može biti dizajniran i obučen offline na baznoj stanici i naravno jedna veličina ovako jednog modela je približno oko 2 KB i samim tim može da bude uskladišten u memoriju samog Edge servera. Dakle, kada bazna stanica, odnosno Edge server dobije zahtev od autonomnog vozila za optimalnu odluku o rasterećenju njegovih resursa, direktnim proračunom, znači izvršavanjem proračuna unapred, u realnom vremenu dobija odgovor o svojoj optimalnoj odluci. Autonomnu vožnju možemo da sagledamo kroz neka 2 osnovna nivoa. To je nivo autonomnog vozila i nivo našeg Edge servera. I vidimo da donekle zaključak, odnosno krajnji izvedba može da se vrši ili preko prvog ili preko drugog nivoa. Ukoliko vršimo našu odluku preko prvog nivoa, to jest tu sama vozila donose svoje zaključke i Te performanse zaključivanja su uglavnom dosta ograničene zbog i samih ograničenih računskih mogućnosti samih vozila. Ukoliko se pak zaključuje edge serverom, tu se uvek javljaju neka dva problema. Privatnost podataka dok se učitavaju podaci putem uplink kanala ograničenog opsega i naravno kašnjenje dok svako to vozilo učita svoje podatke. Zato se primenjuje jedan treći režim krajnje odluke, odnosno režim zajedničkog zaključivanja autonomnog vozila i edge servera. Tako da se ovaj naš obučeni model od malo pre dalje istražuje segmentiranjem tog modela na neke, da kažemo, pliće, na neke dublje slojeve, od kojih ovi SNN slojevi pripadaju samim autonomnim vozilima, dok DNN slojevi pripadaju edge serveru. I u toj jednoj mreži vozila DNN slojeve dele sva vozila. I ukoliko mi imamo, da kažemo, snimak dobrog kvaliteta, autonomno vozilo, odnosno SNN slojevi, na njima će nesmetano moći da izvrše, da kažemo, dobre performanse zaključivanja. Ukoliko pak, da kažem, imamo loš kvalitet snimka, te posebne karakteristike bivaju prebačene na edge server i on naravno rezultate obrade ubrzo vraća do autonomnog vozila gde će one preko svojih elektronskih kontrolnih jedinica i izvršiti krajnji manevar. Za kraj bih samo pomenuo neke od zanimljivosti koje nam donosi autonomna vožnja. Recimo da smo imali nešto da završimo danas ili recimo ovi đaci nisu završili svoj domaći za prvi čas. Autonomna vožnja nam definitivno može pomoći u tome tako što će nas u potpunosti osloboditi bilo kakve usredsređenosti i na put ispred sebe ili na neke komande koje bismo vršili tokom upravljanja samim vozilom. Tako da definitivno ćemo stići da završimo recimo to što smo imali za danas. Krajnje sigurno će nas naše vozilo dovesti do naše ciljane, odnosno krajnje lokacije, tako da kroz neku bližu budućnost uopšte neće biti problem i da mi budemo ova osoba ovde na sedištu. Tako da, eto recimo prilike da nadoknadimo još onih 5 minuta nakon jutarnjeg alarma. Imaćemo definitivno eliminisanje ljudskih grešaka i s tim u vezi naravno znatno smanjenje, ako ne čak i u potpunosti eliminisanje saobraćajnih nezgoda. Imaćemo naravno i poboljšano, odnosno pravovremeno vreme reakcije naših vozila, čak i sa nekim možda veštačkim inteligencijama, samo predviđanje nekog toka saobraćaja. Nećemo sigurno dolaziti u ove situacije tipa kočnice u podjelu. I na kraju, znači, zahvaljujući što samim vozilima, tako i okolnim inteligentnim sistemima kao što su to recimo inteligentni semafor ili pametne raskrsnice, kao i naravno recimo sistemi navođenja samog vozila na puteve manjeg zagušenja, imat ćemo i definitivno poboljšan protok saobraćaja. Toliko od mene i hvala na pažnji.
Hvala puno, Marko. Naš sledeći sagovornik, diplomirani inženjer Ognjen Petar Todorović, načelnik odeljenja za unapređenje urbane mobilnosti Uprave grada Beograda. Izvolite, gospodine.
Sad čujemo. Dobar dan svima. Ako može startuje prezentacija pa da ja odmah pređem na stvar. Pošto sam poslednji govornik, koliko mi je jasno, ja ću se držati mojih obećanih 15 minuta. Možete i da isključite ton slobodno. Može, čak mislim da je bolje da isključite ton. Kao što sam najavljen, znači ja sam načelnik odeljenja za unapređenje urbane mobilnosti, pre toga sam radio 10 godina na planiranju saobraćaja u okviru grada Beograda. U ovoj kratkoj prezentaciji sada ću biti totalno drugačiji od mojih kolega koji su zajedali pre, imali učesnici zatvorničke zajednice, iz privrede, a evo ja predstavljam lokalnu samoupravu. U ovoj kratkoj prezentaciji neću moći da prikažem sve efikasne planove i trendove u urbanom gradu Beogradu, ali ću se osvrnuti na neke projekte i planove, a tako planiramo malo prosječiti Na početku, pre nego što nastavim s prezentacijom, ja volim da uvek započnem sa nekim bazičnim informacijama o Beogradu, pogotovo zbog gostiju iz inostranstva, da znaju sa kakvim se izazovima susrećemo mi koji upravljamo saobraćajem u Beogradu. Ovi osnovni demografski i geografski podaci su pred vama, ali ja ću samo napomenuti možda ono što svi ne znaju, da u gradu Beogradu imamo oko 3,5 miliona putovanja dnevno i to samo u urbanoj zoni. Imamo 5.500 kilometara saobraćajnica, ne metara nego kilometara. Imamo 10.000 raskrsnica, od čega je 650 sa svetlosnim signalima. Model split, koji je jedan od osnovnih parametara saobraćajnog sistema, je ovakav kakav je pred nama prikazan i možemo reći da je on dosta ovako povoljan sa stanovišta pešačenja i javnog transporta u odnosu na druge gradove u Evropi. To možda nije odraz visokog kvaliteta našeg javnog prevoza, nego možda i ekonomskih prilika u zemlji. U odnosu na 50% od ukupnog broja kretanja možemo kazati da je javni prevoz u Beogradu dosta razvijen na podsisteme i kao što vidite na ovom slajdu ovde su prikazane brojevi linija, znači ne vozila nego linija podsistema javnog prevoza. Imamo 226 linija prevoza, autobuskih, 10 tramvajskih, 6 trolejbuskih, 2 beovoza i 24 noćne linije. Do kraja godine imamo i nabavku i kupovinu elektroautobusa, 10 novih elektroautobusa, imamo uspostavljene 2 linije kojima saobraćaju samo elektroautobusi. Kako sam pričao o pokrivenosti i razgranatosti mreže javnog prevoza, evo pogledajte ovu sliku, ona je ovako dosta gusta, prikazana sa ovim šematskim prikazima, a ovde nekom analizom otvorenih podataka ja volim da pokažem ekstreme da bi ljudi videli o čemu se radi u sistemu javnog prevoza. Najduža linija je 52,3 km, a najkraća linija je 2,9 km. Što se tiče frekvencija, imamo raspon frekvencija sleđenja vozila od 2 minuta, znači ako ste propustili jedno vozilo, pogledate na telefon, dignete pogled, evo ga sledeće vozilo, to je linija 26L i najveći period sleđenja vozila je 105 minuta. Linija sa najviše stajališta je 25P sa 54 stajališta i evo jedno stajalište je dobro poznato svima, stajalište Stajam, indeks 495, preko koga prolazi 16 linija. Može sledeći slajd, meni ne ide baterija. Kao što sam rekao, grad Beograd je počeo polako da menja flotu javnog prevoza, okreće se ka zelenoj hijerarhiji, imamo nabavku 10 elektroautobusa, u narednim godinama, koliko se ja upoznat, bit će ih još 80. Šta su izazovi u transportnom sektoru? Naravno, prvi je izgradnja metroa, smanjenje broja stradalih povređenih u saobraćajnim nezgodama, izmeštanje autobuskih terminala, izmeštanje i redefinisanje saobraćaja železničkog u Beogradu, izgradnje i završetak velikih infrastrukturnih projekata i povećanje udela biciklističkog saobraćaja gde smo, ajde kažemo, najslabiji. Naravno, izazov koji su u poslednje vreme dosta proteže u štampi, a i u fokusu javnosti, to je kvalitet vazduha. Ovaj slajd mislim da je, iako je ovako sumoran, ali lepo prikazuje našu situaciju. Šta mi radimo, se borimo ajde kažem, protiv zagađenja vazduha i u smeru razvoja održive urbane mobilnosti. Jedan projekata koje Beograd kontinuirano sprovodi zadnjih 5-6 godina, to je širenje pešačkih zona. Ovde je jedna šema iz projekta. Svi ste, verujem, iz Beograda upoznati ili posetioci kako lepo napreduje taj projekat širenja. Imamo ovde fotografiju koja prikazuje rekonstrukciju Trga Republike gde su povećane pešačke površine i usporen saobraćaj. Imamo izgradnju jednog novog trga ili rekonstrukciju starog, ali sad imamo znatno veće pešačke površine. Znači dali smo veće površine pešacima, uzeli smo vozilima. Pored toga što proširujemo pešačke zone, mi unapređujemo njihovo funkcionisanje. Evo ga jedan lep projekat, možda ljudi nisu ni svesni šta radi ovaj stup pametni. To on ima automatsko prepoznavanje tablica i očekavanje tagova, jedan mali semaforčić i jedan potapajući stubić koji faktički vrši automatsku kontrolu pristupa pešačkoj zoni. Pre toga svi smo bili svedoci jednog, ajde kažem, nekontrolisanog haosa vezano za dostavu centralne zone. Sad je ovo uvedeno u red. Svako vozilo zna tačno na koji stubić ulazi, u koliko sati mora da se pojavi, u koliko sati mora da izađe i mogu vam reći funkcioniše 100% bez ikakvih prijatnosti. U cilju unapređenja funkcionisanja pešačke zone jedan minibus električni bez lokalne emisije štetnih gasova, bez buke, koji prenosi turiste ili slabo putničke ljude. 7 putnika može imati 4 vozila, interval je čini se na 10 minuta, 2,2 km trasicu oko i kroz pešačku zonu i što je najbitnije besplatno korišćenje. U Smart City konceptu, kažem, sprovodimo već projekat nekog pametnog parkiranja. Imamo sad na ulici oko 3.500 parking senzora sa ovim nekim infotablama koje nam daju neke korisne informacije gdje možemo naći najbliže parking mesto. 39. godine prošlog veka uveden prvi semafor ispred Skupštine grada. Posle toga stigli smo, ajde kažemo, do nekih modernih razvoja semafora. Sada u Beogradu je takva situacija da imamo jedan veliki projekat koji realizujemo zajedno sa Siemensom, da širimo, to jest imamo upravljački centar za upravljanje saobraćajem na koji su povezani optičkim kablovima većina semafora u gradu Beogradu. Rekonstrukcijom sad kroz ovaj projekat predviđena je rekonstrukcija 322 raskrsnice, uvodi se sezonski adaptibilni sistem upravljanja saobraćaja, znači gde će, kažem, traffic management biti prilagođen zahtevima koji dolaze direktno od vozila. To jest ne unutar raskrsnice, nego u celoj zoni će se raditi optimizacija, tako da su neki očekivani efekti od 10 do 15% manje vremenskih gubitaka i poboljšanja protoka saobraćaja. Jedna od raskrsnica koja je urađena u okviru ove rekonstrukcije i ova kod Doma omladine, koja se i popularno zove u našim saobraćajnim krugovima Beogradska Šibuja, podsjeća na onu japansku raskrsnicu, gde inače stručan naziv je za ovo ekskluzivna pešačka faza, gde u okviru jedne faze rada semaforskog signala svi pešaci dobijaju ekskluzivu da mogu ići odakle hoće i gde hoće, što je pokazalo dosta dobre efekte i primljeno je u narodu. Sledeći projekat koji je, ajde kažem, jako skoro pred nama, to je razvoj bike sharing sistema u gradu Beogradu. Plan grada Beograda je da postavimo na ulice 1000 električnih bicikala za javnu upotrebu na 150 bike sharing stanica, što će dosta doprineti urbanoj mobilnosti i razvoj tog vida saobraćaja. Što se tiče punjača, sada ja kažem, prelazim na one delove koji su nam u planu. Ovo su do sada bili neki projekti koji su već započeli ili su završeni. Ovo je stanje sada sa stanicama za punjenje električnih vozila. Sad, žao mi što nisu svi ti podaci objedinjeni, možda mi neke stanice, to jest ne možda, nego sigurno mi fale. Trenutno situacija kog se ja našao da ih imamo 22, Sad hoću da kažem da Sekretarijat za saobraćaj ima u svom finansijskom planu javnu nabavku za izradu plana mreže električnih punjača koji ćemo realizovati, nadam se, jako skoro, što će nam dati neki planski strateški osnov dalje da razvijamo ovu elektromobilnost, jer moramo ljudima ponuditi punjačka mesta da bi ih stimulisali da koriste elektrovozila. Ovo je otprilike neki šematski prikaz kako je to zamišljeno da se izgleda. O tome ovdje ima mnogo kompetentnih ljudi da pričaju, pa ću ja preskočiti onda taj slajd. Pričam sledeći slajd koji je prikaz vizije urbane mobilnosti kakvu nam donosi Evropska komisija. Ova je fotografija sa naslovnice Urban Mobility Package 2.0. Znači ovo je, ajde kažem, iz zvaničnog paketa za razvoj urbane mobilnosti u Evropskoj uniji. Ovo da smo prikazivali ovaj slajd pre jedno samo 5 godina, mislili bi da je u pitanju neki futuristički crtani film, animirani film. Sada je već ovo velika realnost i svaki od ovih segmenata slika može da bude jedan pojedinačan projekt koji se radi baš u ovom 8 Urban Mobility Hubu. Nadam se. Prilog tome da kažem da ovo nije samo daleka vizija i da je to vizija Evrope. Ovo je jedan slajd koji prikazuje naše viđenje Mobility as a Service integracije koje otprilike korespondira i sa onom fotografijom od malo pre, to je sa šemom od malo pre, a ova šema MAS sistema za Beograd je predstavljena u Sustainable Urban Mobility planu grada Beograda koji je usvojen prošle godine. Inače, za taj plan smo dobili, ajde kažemo, nagradu od strane Evropske komisije. Nije bila prva nagrada, ali smo bili u finalu, među prva 3. Grenoble je pobedio, ali svakako da je veliko priznanje da je Beograd bio među 3 najbolja evropska plana u 2020. i da smo jedini gradi koji nije iz Evropske unije koji se našao ikada u finalu za izbor najboljeg sumpa. Prilikom sump ceremonije koja je bila održana u Briselu, Beograd je bio predstavljen kroz ovaj mali film od minut i po. Ja ga upravo puštam, možete dodati malo tona i time završavam moju prezentaciju i zahvaljujem se svima. Pogledajte ovaj filmić od minut koji prikazuje šta smo mi radili, čime smo se prezivali. Zahvaljujem se svima na pažnji.
Hvala gospodinu Todoroviću i vama na izlaganju i ovime završavamo 4. Hoćete? Izvolite.
Zahvalim svima koji su izdržali.
Evo par rečenica samo. Zahvaljujem svima koji su pre svega izdržali ovu sesiju, jer malo je bila duža od onog planiranog, malo više nego što su planirali, ali eto, imaju onih koji su ostali, neki silom, neki milom. Pre svega, da krenemo od kraja, Ognjenova prezentacija koja je možda odudarala od neke priče prethodnika, kako je on sam rekao, je u stvari finiširala ovu priču, bar po mom utisku, onako sa Beogradom, na kraju tu smo, tu živimo i sa nečim što daje neki podstrek da se dešava nešto u tom smislu, da ima nekih pomaka i eto, te informacije su onako prijatne, ja mislim, za svako ko je ovde i ko očekuje da u nekim boljim uslovima čekamo neku sutrašnju priču. Mi smo kao organizacija, eto, neko ko je na tom istom pravcu, pa mislim da će biti neke budućnosti u toj saradnji, da ima nekog potencijala. Daliboru bi se posebno zahvalio i rekao bi samo nešto da je njegov primer specifičan ovako u celom ovom našem životnom okruženju, da čovek koji je rođen u Francuskoj, u Parizu, doktorirao, završio tamo škole i žena i tako dalje, dođu ovde sa 3 dece u Srbiju i nađu neku budućnost. Mi smo se sticajem okolnosti spojili, on je nas pronašao, onda smo se zajedno pronašli, što kaže, i eto, guramo dalje. To nije jedini projekat. Tako. On sutra ide, ovo i za Ognjena možda informaciju vjerojatno zna, ili ne znam, nije bitno, i za Ivanu. Nas su pozvali sutra na jednu konferenciju, da je nazovem tako, NAAEV nas je pozvao. Oni su nešto krenuli ovom temom da se bave, kažem krenuli, jer mislim da do sada nisu bili u toj temi. To nije loše s jedne strane, jer oni imaju neke prodore i neke ulaze koje možda mi nemamo. I Dalibor će biti naš predstavnik na tom nekom njihovom skupu. Sad da ne ulazim u tu priču ko će sve biti, ne znam nije tačno, ali eto, oni prave neku priču. Otprilike, koliko se ja razumeo neku informaciju, oni su delegirani, da kažem pod navodnicima, od same vlade da budu koordinatori neke teme koje, eto, the future of mobility, na primjer, neka priča u kojoj se nalazi sad oni, šta će oni tu da rade i kako, sad ne ulazim dalje, ali ako budu hteli i ako budu umeli, oni mogu pomere možda tamo negde gde mi ne možemo ili bar možemo mnogo teže. Ništa više da ne ispunimo ono vreme, već smo prekoračili sve. Hvala još jedan puta svima. Vidjet ćemo se uskoro, se nadam, i lično, a i ovako. I Marku bi posebno još zahvalio na neki način. Upisat ćemo te u knjigu utisaka kao prezentera koji je prvi put se pojavio na nekoj prezentaciji, tako da, a pazi samo nešto, Branko Kovačević je za tebe rekao, tako si ti došao ovde, u stvari, na neki, mislim, došao bi bez toga, verovatno, da li Neško, da li ko, ali Branko je povukao nogu i rekao je, slušaj, bio sam, kaže, na diplomskog jednog malog, kaže, mali je genije. Kažem, daj da ga vidimo, dajte, toliko za danas. Hvala.
Hvala najljepše, prijetno.
By the year 2030, 60% of the world's population will live in urban areas. There are already around 1.2 billion passenger vehicles on the road today. By 2030, this figure is projected to reach 1.6 billion. As cities continue to grow, the sustainable transportation of people and goods will become ever more important and complex. For many of today's city dwellers, mobility means stress, congestion, and delays. Getting around can also be unhealthy and even unsafe. If nothing changes, these problems will only get worse. This is why we urgently need to address the social, environmental, and economic challenges facing urban mobility. Our challenge is to upgrade our infrastructure to enable greater choice for those who need to get to their destination quickly, reliably, and cheaply. To do this, we must integrate many different modes of mobility to create a more flexible and seamless user experience. So, what could this future of urban mobility look like? Meet the Osorio family. João, Flavia, Eduardo, and their dog Pele live on the outskirts of Rio. Their neighborhood is a dedicated auto-free zone. Bike lanes and wide tree-lined pavements make walking and cycling safe and convenient. Public transport is cheap, dependable, comfortable, and safe. The Osorio family uses their neighborhood's integrated mobility service, which provides access to a variety of private transport options, including citywide e-scooters, bicycles, and a car-sharing program. Flavia works in an office across town. She loves Rio's new dedicated bicycle and scooter highways, which have automated driving lanes, charging points, and convenient parking for her electric moped. She uses the dashboard on her scooter to choose the route with the cleanest air and least congestion. Eduardo likes to walk to his new school. His ambient glasses map his location as he walks, helping him find his way and providing information about his surroundings. This morning, Eduardo is learning about the different bird species that live in his neighborhood. Joao is a postman who spends most of his time at the local logistics centre. He loves the neighbourhood's new consolidation scheme, where all mail and household deliveries get pulled, unpacked and sent straight to each home through pneumatic tubes. To get around, Joao either walks or uses the metro system, planning in advance to board trains with the lowest fares and most empty seats. On the weekend, the family uses the local car-sharing hub to escape the city, taking Peli out for walks and visiting their extended family. This is just one scenario for what the future of urban mobility could look like, encompassing vehicle sharing and smart traffic management, and placing a greater focus on walking, cycling, and micromobility.
Vienna is moving together. Like other modern cities, Vienna aims to ensure that everyone gets from A to B safely, regardless of how much they earn, where they live, or what their needs are. Over 5 million trips are made in Vienna every day. On foot, by bike, by public transport or by car. Vienna will continue to grow in the coming years and everyone wants to stay mobile. If our current mobility patterns continue, we'll see a 12% increase in car traffic by 2025, which would mean more noise, more air pollution and more traffic congestion. Vienna is looking ahead with its new urban mobility concept. By 2025, eco-friendly means of transport are to account for 80% of all trips made in Vienna, so the city can maintain its high quality of life. Future urban mobility will seamlessly integrate different transport modes and promote car and bike sharing. Owning a car in the city is 20 times more expensive than buying an annual pass for the Vienna public transport network. More than a third of the city's population are already annual pass holders. Cycling and walking are good for your health. Just 30 minutes per day increase your life expectancy by several years. 2/3 of Vienna's road space is currently reserved for cars, which are parked 95% of the time. Fewer cars means more space for walking, playing and meeting other people. It also frees up road space for deliveries and other trips that must be made by car. Vienna is expanding its public transport network, making cycling and walking even more attractive and facilitating car and bike share systems. In the future, urban mobility will bring us all together, saving time and money, keeping us healthy and making the city more attractive for everyone.
Green Mobility presents Your City Car. Come along for the ride and we'll tell you all about it. It's an exciting concept and we promise it'll be worth it. We are based in Copenhagen and already have a partner in Oslo. Your City Car is an app which gives you access to a fleet of electric cars. Download Your City Car app, register, upload a picture of your driver's license. Soon, your mobile phone will become your key to a large fleet of city cars. In the app, you will find a location of all the cars and how far you can drive on the battery. Now you can reserve a car nearby, and your city car is reserved specifically for you for up to 30 minutes. Within this time, you can unlock and drive. You only pay per minute for the time you have the car. You can also press stop over in the app so that you can run errands and continue your trip in the same car. Your trip is only finished when you press end trip in the app. Parking is free and you can park your city car in most public parking spaces within the city zone. You can see the zone on the Green Mobility website and in the app. If you drive outside the zone, a green light will turn red. You are allowed to drive outside the zone, but you must be within the zone in order to end your trip. You can find more information about parking inside your city car. We have hotspots around the city with designated parking for your city car. You don't need to worry about charging the car. We'll take care of that. You'll find all the answers on the Green Mobility website and in your city car app. And by the way, in all the city cars, there is a button. Push it and you can talk with a city car whiz who will answer all your questions. Simple as that.
In the beginning, it was about instinct, moving from place to place. Initially for survival, then to pioneer. Today, we travel because we can. On vacation to business meetings, from point A to point B isn't just a car ride. It's a train, it's a plane, and soon even a space flight away. But what about efficiency? There's a gap between imagination and actualization.
You can go anywhere on Earth, anywhere. Like, you can actually go to, like, the top of Mount Everest. There's no place you can't go, anywhere. So I think we've explored the boundaries, at least the physical boundaries of Earth, quite thoroughly.
You're describing how we can go anywhere on Earth now, but the methods with which we use to get there, do you think they're efficient?
The most important thing that needs to happen is the transition of transportation to electric. The ideal long-distance transportation mechanism is a supersonic vertical takeoff and landing electric jet. And then there's a special case of cities which have a lot of travel between them, below about 500 miles of distance, where I think the Hyperloop would be useful. It is a special case solution, because once the distances get long, then the amount of time that an aircraft takes to ascend and land, which is most of what it does in a 500-mile trip, that percentage declines, and then it's better to just use aircraft. I know that there are various companies that are trying to create the Hyperloop, and honestly, I think it's a lot easier than people think.
The blueprints are pretty complicated.
Well, blueprints are always kind of complicated, and I mean, yes, there's math, but it's really not that hard.
It still sounds pretty complicated, Elon.
It's like a tube with an air hockey table. It's just a low-pressure tube with a pod in it that runs on air bearings, on air skis, with an air compressor on the front that's taking the high-pressure air buildup on the nose and pumping it through the air skis. It's really, I swear, it's not that hard.
Three, 2, 1, go!
This is our third Hyperloop competition, and I've seen them all, and every year the pods get better and better.
There hasn't been any major innovation in the transportation industry in over 100 years. We want this Hyperloop system to be built because it'll be like this major web that's connecting the entire United States and maybe the entire world.
In this very dark video, you're going to see what we did at 10:30 last night. We made our pod go over 50 kilometers an hour in just 20 meters. It was the most intense and amazing experiences of our whole time in this competition.
At this point, the Delft pod has been loaded into the Hyperloop test track and a vacuum has been established. All systems are go! 4, 3, 2, 1,
That was a great race with a top speed of 88 miles per hour.
Five, 4, 3, 2, 1, launch!
when the run was finished, the pod stopped, we were all like cheering and we were really excited and happy. Then when we saw the faces of the people from SpaceX, just like, maybe there's a problem.
The speed you saw on the screen was broadcasted from the team's pod. However, our independent check showed a speed of around 53 miles per hour.
What you're doing here is one of those things that makes people excited about the future. Those things are rare. It actually energizes me about the future that you guys are so excited about doing this. It's really something that's like, it's next level stuff. Congratulations.
This year we're participating in the third competition. And so far we've won the first two competitions and we're trying to defend our title now, hopefully being the fastest pod yet again. We have had some issues with our pod, but we're confident that we'll get to roughly our target speed, which is between 500 and 600 kilometers an hour.
Alrighty folks, we are ready for our final pod race of the day!
3, 2, 1, and go! Yes!
We are excited to announce that Team VAR has just achieved 284 miles an hour!
This represents a new Hyperloop test track record!
Just an awesome feeling and just the disbelief, really, to actually have arrived here and to have won the competition after all this time. Just looking at the video of it, it was clear that it was faster than last year.